Hi guys, welcome back to my channel. So today we are going to study quantity of the wastewater. So the total quantity of the wastewater will be weather flow and the dry weather flow, whereas the wet weather flow is the additional amount of water which comes from the rainwater, and the dry weather flow is the quantity of water that flows in dry season when there is no storm or the rainwater. So the total quantity of water for sewer will be due to the wet weather flow and the dry weather flow. For the calculation of the quantity of wet weather flow, we can use the rational formula. This British Ministry of Health formula for intensity of rainfall. You guys can just screenshot this page. This is all the formula that we will use in this chapter, and you can, by using all this formula, you can solve almost all the problems in this chapter. From the rational formula, we have Q is equal to CIA by 360, whereas C is the runoff coefficient, I is the intensity of rainfall, which is in mm per hour, and A is in hectares, that is the area. On British Ministry of Health formula for intensity of rainfall, we have I is equal to A by T plus B, whereas A and B are the constants. Also, I is equal to 760 by T plus 20 when the duration of a storm is from 5 to 20 minutes, when the rainfall is only for 5 to 20 minutes, and I is equal to 1020 by T plus 20 when the rainfall is from 20 to 100 minutes. So this is the rational formula that we use to calculate the wet weather flow, and for the dry weather flow we used the total quantity of sewage will be 0.8 times of the rate of the water supply into peak factor into the population. So peak factor we generally take 2 to 4 or if given in question, and the total quantity of sewage will be quantity of storm plus sewage. So this is liter per capita per day. If you have to convert this in cubic meter per second, then just divide the answer by 1000 into 24 into 3600, where 1000 is used to convert the liter into cubic meter and 24 into 3600 is used to convert the day into second. Now we will solve a numerical from this chapter. This numerical we have asked to determine the design discharge for a combined sewer given area is 300 hectares. So area is equal to 300 hectares. Water supply rate is equal to 100 LPCD. Then peak factor is 2.5. So peak factor is equal to 2.5. The projected population of the area, the population is 50,000. So total population is equal to 50,000. Only 85% of water supply contributes for the sewage. So here quantity of sanitary sewage, Q sewage, is equal to 85% of water supply rate. So 0.85 times the water supply rate into population into peak factor, which will be equal to 0.85 times of 100 divided by, to convert the LPCD in cubic meter per second we have to divide with 1000 into 24 into 3600. To convert liter into cubic meter we have to divide by 1000, and day in second 24 into 3600. So here 1000 into 24 into 3600 times this population is 50,000 into peak factor here is 2.5, which will be equal to 0.85 into 100 right, 1000 into 24 into 3600 into 2.5, which will be equal to 0.123 cubic meter per second. Now to calculate the quantity of storm water, here we have given the runoff coefficient for different percentage of area. So total runoff coefficient total runoff coefficient will be equal to C1A1 plus C2A2 plus C3A3 divided by A1 plus A2 plus A3. So here runoff coefficient for first area is 0.9. 0.9 into A1 is 40% of the total area, that will be 0.4 plus C2 is 0.8. So 0.8 times of 0.3 plus 0.7 times remaining. So 40 plus 30 will be 70% and remaining will be 30%. So 0.3 divided by 0.4 times 0 plus 0.3 plus 0.3, which will be equal to 0.9 into 0.4 plus 0.8 into 0.3 plus 0.7 into 0.3 divided by 0.4 plus 0.3 plus 0.3 is 0.81. Now quantity of storm water, Q storm, is equal to CIA by 360. So we have already calculated the runoff coefficient. For intensity we have the formula. So from British for intensity of rainfall. So total time of concentration of rainfall is 90 minutes. T is equal to 90 minutes. For 20 to 100 minutes, I is equal to 1020 by T plus 20. So here the intensity will be is equal to 1020 by T plus 20, which is equal to 1020 by 90 plus 20 is equal to 1020 by 90 100, which is 9.27 mm per hour. Now therefore the quantity of storm water will be equal to CIA by 360, which is equal to 0.81 times 9.27 times the total area. Total area is 300 hectares, so 300 divided by 360, which is equal to 0.81 into 9.27 into 300 by 360 is 6.26 cubic meter per second. Hence quantity of sewage for combined sewer is equal to quantity of sewage, quantity of sanitary sewage plus quantity of storm water, which will be equal to, here we have calculated the quantity of sanitary is 0.123, so 0.123 plus 6.26, which is equal to 0.123 plus 6.26 is equal to 6.383 cubic meter per second will be the required answer. We will solve more numerical of this chapter in the upcoming videos, so please subscribe the channel. Thank you.